Welcome to this tutorial on building your first AI model. Artificial intelligence, AI, might seem complex, but with the right approach, anyone can start creating their own models. In this video, we will walk through the entire process step by step, from understanding the basics to training your first AI model. Whether you're a beginner or have some experience in programming, this tutorial will set you on the right path. Let's dive in. Before jumping into coding, it's important to understand what an AI model is. At its core, an AI model is a program designed to perform a specific task by learning from data. The most common type of AI model is built using machine learning, where the system is trained to recognize patterns and make predictions. For example, AI models can classify images, translate text, or even predict future trends. In this tutorial, we'll build a simple model that predicts house prices based on features like size and location. To build an AI model, you'll need a few tools. Python is the most popular language for AI development due to its simplicity and vast libraries. Install libraries like TensorFlow or PyTorch for building models, and Pandas and NumPy for data manipulation. Use an integrated development environment like Jupyter Notebook or Visual Studio Code to write and test your code. To get started, open your terminal or command prompt and type the following commands to install the necessary libraries. Pip install TensorFlow Pandas NumPy Matplotlib. This command will install TensorFlow, Pandas, NumPy, and Matplotlib for data visualization. AI models rely on data to learn. The first step is to collect or use a pre-existing dataset. For this tutorial, we'll use a sample dataset of house prices. Download the dataset or use an online source like Kaggle. Load the data into your Python script using Pandas. Import Pandas as PD, data equals PD read_CSV, house_prices.csv, print data.head. Inspect your data to understand its structure. You'll typically need to clean the data by handling missing values, removing duplicates, and standardizing formats. Here's an example of cleaning. Hashtag handle missing values, data equals data.dropna. Hashtag standardize column names, data.columns equals kernel strip.lower for call and data.columns. Next, split your dataset into training and testing sets. The training set will be used to train the model, while the testing set will evaluate its performance. From sklern.model_selection import train_test_split, x equals data, size, location, y equals data, price, x_train, x_test, y_train, y_test equals train_test_split, xy, test_size equals 0.2, random_state equals 42. Here, x contains the features and y contains the target variable. Now it's time to build the AI model. For simplicity, we'll use a linear regression model, a common starting point for beginners. From TensorFlow.keras.models import sequential. From TensorFlow.keras.layers import dense. Hashtag build the model. Model equals sequential. Dense 64. Activation equals rel. Input_shape sad face x_train.shape 1, dense 1. Hashtag compile the model. Model.compile. Optimizer equals Atom. Loss equals MSE. Metric sad face may. The model has one hidden layer with 64 neurons and uses the Atom optimizer with mean squared error, MSE, as the loss function. Train the model using the training data. History equals model.fit, x_train, y_train, epochs equals 50, validation_split equals 0.2, batch_size equals 32. Here, epochs defines how many times the model will see the entire dataset, and batch_size controls the number of samples processed at a time. After training, evaluate your model's performance using the testing set. Eval_results equals model.evaluate, x_test, y_test, print f test loss. Eval_results 0 test ME. Eval_results 1. This step helps determine how well the model generalizes to new data. You can now use the trained model to make predictions. Predictions equals model.predict x_test. 5. Print predicted prices. Predictions, print actual prices, y_test. 5.values. Visualize the training process and results using Matplotlib. Import matplotlib.pyplot as PLT. Hashtag plot training and validation loss. plt.plot. History.history. loss. Label equals training loss. plt.plot, history.history, val_loss. Label equals validation loss. plt.legend, plt.label, epochs. plt.label, loss. plt.title, model training performance. plt.show. Congratulations! You've successfully built your first AI model. This tutorial covered the basics of understanding, building, and training an AI model step by step. While this is a simple example, the same principles apply to more complex projects. Keep experimenting with different datasets and models to enhance your skills. Don't forget to like, comment, and subscribe for more AI tutorials. Happy learning!